So, with our second day here of working with these irregular shaped squares, what did we learn yesterday? We started off yesterday, right? We took a look at this square right here, right? We found its area by either boxing in the square around it or working on getting triangles and squares inside of it, right? We also found out how we were able to prove this was a square. Like, how do we prove the right angles of this thing? Who remembers from yesterday? How do we prove that this was a right angle? That was a right angle? All four of these were right angles. No, that's not how we proved it. What a little bit more information. Negative reciprocal slopes, right? This had a slope of 1/3. This was -3/1, right? And all the way around, they were the same, right? So when these negative reciprocal slope lines meet, they form a right angle. Right angle. Now, when a vertical line met a horizontal line, that was the figure on the bottom, right? Those were automatically perpendicular. But these aren't vertical, are they? These are diagonals. So we had to count the slope. And when the slopes are negative reciprocals of each other, they form a right angle. Okay? Then we came over to here and we started working on drawing a square that had certain areas. And the first one we started out with was 1, right? We did a 1x1 square, right? Because we knew that area is length times width, right? And we knew that 1 times 1 equaled 1, right? And we had an easy time with the 4 because we knew that this was a 2x2, and we knew that 2 times 2 equals 4. But why was 2 different? Why was the area of 2 different? It doesn't sit up like a nice perfect square like the other ones, right? Why? We had to do some work to find this one out, right? Some people did things. We actually found them several different ways yesterday, right? Some people drew 4 boxes and then took half of each box to find their area of 2, right? 0.5 times 4, right? Some people boxed the whole shape. Get that? Right? And then we worked inside of that, right? So we did things so a few people did some things differently to find it, but eventually found out that square root of 2 is or what the area of 2 is for this shape, because this between 1 and 4, which are perfect squares, right? They sit up vertical line, horizontal line. This was kind of more of an irregular shaped square, right? Tilted. So we left off yesterday, I believe, on number 5, right? I think we got to 9, right? We did talk about 9, right? Being a 3, with an area of 9 where the sides of 9, that was the next perfect square size up, right? 3x3. So we left off with the area of 5. Did anyone think they came up with it? Well, again, let's look at it this way. Maybe this is a good strategy to help try to solve these. The area of 5 falls between what 2 areas of perfect squares? Which 2 perfect squares does that area of 5 fall between? The 9 and 4, right? The 2x2 and the 3x3, right? So we can't draw a 2x2 square because that would be smaller than the actual shape, right? Bigger area down here. So if you drew a 3x3, if you drew a 3x3 square, that has an area of what? 9, right? All right, and we have to subtract some part inside of 9 to get to 5, right? What number is going to make that work? 4, right? 9 minus 4. So up top, in the first one, when we box this guy in, We knew that that was an area of 4, right? And then each of these little areas here were a half, right? Half, half, and half gave us 2. So we subtracted 2 from that to give us 2, right? Well, the same idea down here. So if a 1 by 1 triangle, we knew that, gave us a total area of what? 2, right? That's what we subtracted, right? Half, 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 and half. There's going to be 4 triangles within that shape because there's 4 sides, right? So what do you think? What size triangle do you think will give us an area of 1? Because if there's 4 of these, right? If there's 4 triangles, we have to have an area of 4. Each triangle has to have an area of 1, right? So if the 1 by 1 has an area of 2, each of them being a half, right? We need to have a total area of 4 where each triangle has an area of 1. So what size triangle can have an area of 1? We know it's got to be bigger than a 1 by 1, right? That means when you have one base, right? One height, one base. So what could be a little bit bigger than that? What could be a little bit bigger than a 1 by 1 triangle? Base of 1, height of 1. 1 by 1.5? It'd be hard to take it 1.5, half of that, wouldn't it? What's the next size up? 1 by 2? So if you did a 1 by 2 triangle, so half of 2 is 1, right? Times 1 is 1. So that's our triangle, right? So if I go over here, watch this. If the height is 1, here's my 1 by 2 triangle, right? So over here there's 1, 1, 2. There's my figure. Anyone get that shape from yesterday? All these triangles, this is a 1 by 2. 1 by 2. 1 by 2. 1 by 2. And we subtract that total area of 4, when you add them all up, that gives us our area of 5, the clear figure. All right, so we're going to take a pause, and we're going to have you work on the one of 8. Remember, 8 is still between, right, the area. I thought, I could have swore yesterday when we were walking around, there were some groups that actually found 8 before you found 5. So if you found 8 and want to move on to some other sizes, great. But we're going to give you about 5 minutes to see if you can just do number 8. Just number 8 with your team and see what you can come up with. All right? We got to draw a square that has an area of 8. All right? All right, we're going to pause it and take some time to work on that. Go. All right, some groups did a really nice job of, they did this. They boxed in the 4 by 4 shape. Right? Well, we know a 4 by 4 square is what? What area? 16. So now, how do we go about finding the triangles? Well, we know to get 8, we have to subtract 8, right? And we knew just from up here, a 1 by 2 triangle gave us an area of what? This had an area of 1, right? Whoa. How did I lose that all of a sudden? So this had an area of 1. There was 4 of them. It gave us 4, right? We got to go bigger than that, right? We need, if there are 4 triangles and they come up to an area of 8, each triangle has to have an area of what? 2, right? Because 2, 2, 2, and 2 gives us 8. So what kind of triangle has an area of 2? Well, if a 1 by 2 has an area of 1, 2 by 2. Because half of 2 is 1, times 2 is 2. So if we just go 2 over 2 high, so just connect the dots, it basically looks like a big diamond. So if our area 2 was like a 1 carat diamond, that's like a 2 carat diamond. That's double the size, right? So there's our 8, because this has an area of 2. That does, and that does. And this is what we're taking away. Now, there were some people that looked at the inside and went, well, I can make 4 boxes here. Right? So 1, 2, 3, 4. And then I got triangles that can cut in half. So these halves become 1, 2, 3, and then 4. So 4 and 4 was 8. So I saw some people who did that also. All right? So it's basically a big old diamond. All right, so while you were working, I told you number 10 you already knew the answer to. Why is that? Why do you already know the answer to number 10? Nobody's paying attention. The very first thing we did on the front side of the paper. Right? That square, what was our answer when we calculated the area? 10. And they're trying, it's a 1 by 3, so it's here. Those are the parts we're taking out, right? So every corner gets that third dot from the top or from a corner. 3 from here, 3 from here, 3 from here, 3 from here. And we did that right on the front. And again, this one we knew because, again, if we box in the figure, if we prove it with our work, again, that's a 4 by 4 square, right? So 16. Now each of these guys, if it's a 1 by 3, each of these are 1.5. Right? What's 1.5 times 4? 6. Again, we did this on the front. That's how we get the 10 square units. All right? Well, what was 16? Because we've been drawing a lot of 16 already. 16 should be a what? A nice looking 4 by 4 square, right? Which is basically boxing the dots, right? Because 4 times 4 gives us 16. So this was our next perfect square, right? From 1, area of 1, area of 4, area of 9, now area of 16. Gives us a nice perfect square again. Now our last question says 25. You have to add more dots. Why? Why do we have to add more dots to an area of 25? Blake?
5 times 5.
Right. Right. 5 times 5 is 25. So if I go across starting here, I only got 4 dots. So let's say if we just go over the line and make our square, we can make it a little bit bigger. So we have a 5 by 5 square because we know that 5 times 5 is 25. So we had to add more dots because we didn't have enough surface area to draw our figure, right? So you notice the perfect squares on this sheet were a 1 by 1, gave us an area of 1, a 2 by 2, which gave us an area of 4, a 3 by 3, which gave us an area of 9, a 4 by 4, which gave us an area of 16, and a 5 by 5, which gave us an area of 25. So instead of drawing this, let's think about this question. They want us to draw, but instead of drawing, let's just think. Can you find any squares with other areas that are between 16 and that have an area between 16 and 25? What would those squares be? What would be the next area up from 16? Huh? Uh, think about what we could draw inside of here. I mean, if we start messing around with the triangles, let's see here. Not having the dots is a, let's see here. So there's one. This is a 2 by 3 triangle. So if we know this is 25, and I'm taking a 2 by 3, half of 2 is 1, so, and times 3 is 3. So each of these are 3. So there's 4 3s, which give us what? 12. Well, that wouldn't fit off after 16, right? But here's one with an area of 13, right? Because 25 minus 12 is 13. So that would fall between the area of 10 and 16. So those are some of the ways that we can come up with other areas. What were the easiest squares to draw? What were the easiest ones? What ones did you have no problem with whatsoever, Kelly? 4 by 4, all the perfect squares, right? All the squares that had a vertical and horizontal line, you guys got with ease, right? Those were nice and easy to draw. Because that same number times itself gave you that perfect square. Where all these other ones, which didn't have those nice, perfect, nice, easy numbers, forced that square to do what? Tilt, right? It wasn't a perfect square. So in Investigation 2.2, we're going to get into why is that. So you can see the numbers, again, that are perfect squares, which is a number times itself to get that number. And these are nice, beautiful looking whole numbers, right? 2 times 2, 3 times 3. These other numbers that you see for the areas of 2, 5, 8, they're not a nice number to multiply by itself to get to that number, right? That square is not going to work. It takes a little bit more thought. You're probably going to need a calculator to figure that out because you're talking about a very unique number as opposed to 1, 2, 3, 4, and 5. All right? All right, so that's going to do it for the video.